Welcome back. So today we're going to continue talking about these exponential models, but this time we're going to talk about money. So when you give your money to a bank, okay, you make a certain amount of interest every so often, right? So most kids think of interest as something you just get at the end of every year. However, what banks actually do is use a process called compounding. Okay, they compound your interest. And the cool thing is, the more that you compound the interest, the more money you're making because you start making interest on your interest that's already been compounded. So this probably sounds a little bit odd, but it's actually a really cool process because this is exactly what happens to your money when you put your money into a bank. Now, this formula is a little bit more complicated, okay? Not by very much. It's still the same structure, okay? You're still talking about how much money am I starting with? It's called the principal amount. So how much money are you handing the bank? You still have the plus one. This time you have that rate divided by the number of times it's compounded. And this time your interest or your time frame is that time multiplied by how many times is it compounded. So here is some vocabulary for this section to keep in mind. All right. So if it's compounded annually, that's going to be an n value of 1. Semi-annually is an n value of 2. Quarterly is an n of 4. Monthly is an n of 12. I think on one worksheet I included weekly. There's 52 weeks in a year, so that would be an n of 52. If it's compounded every day, that's going to be n of 365, except, of course, on leap years, but we're just not going to handle that mess. So, what are we going to do? Well, just like before, we're going to identify each and every one of those pieces, type it into the calculator, and then obviously all of these are monetary values. Here, we're going to be talking about money because this is what happens in the bank. So of course, you're going to go to 2 decimal places unless you're told otherwise. So let's see how this looks. So an amount of $1,500 is deposited in a bank paying an interest rate of 4.3% compounded quarterly. What is the balance after 6 years? All right, so we need to find each of those pieces. So this time there are a couple more pieces that we're having to find, but they're pretty easy to pick out. I'm starting with $1,500. That's how much I'm handing the bank. My interest rate is 4.3%. So of course, as a decimal, move it over twice. You get 0.043. Quarterly. Quarterly is going to be an n of 4. There's 4 quarters in a year. And my time frame is 6 years. Once you've identified all of those pieces, now I'm going to put it in the formula. 1,500 times 1 plus 0.043 divided by 4 times 4 or to the 4 times 6 power. Now, the really neat thing here is, even though this looks like a huge mess, you can actually just plug this into the calculator. The calculator will give you the right value, all right? You just have to plug it in exactly as I'm showing you there. So let's practice plugging this in. This is a great time. If you have your calculator handy, you should be typing this in with me, okay? That's going to be the best way to remember these keystrokes and the formula. 1,500, 1 plus 0.043 divided by 4, divided by 4 to the, now this is where you have to be very careful. You need to make sure you put this in parentheses. If you don't have that in parentheses, the calculator will not give you the right answer. Okay, that exponent piece must be in parentheses. Hit enter, and there you have it. So Super, super simple. As long as you use your graphing calculator, as long as you know that this is how you type it in, so easy to get the answer. So you have $1,938, $1,938 and 84 cents. Right? And that's really all you have to do for these problems, okay? Identify the pieces, show the formula. I do need to see that formula, show yourself plugging it in, and then just use the calculator to pop out an answer. Okay, that is it. So, let's try the next one. The same $1,500 is deposited using that same interest rate, but this time is compounded monthly. What is the balance after 6 years? So we're using the same figures as before. So the principal amount, I'm handing $1,500 to the bank at 4.3% interest, which as a decimal would be that. Compounded monthly. There are 12 months in a year. And then, of course, the time is 6 years. So let's plug that in now. Okay. So your money is going to be 1,500. 1 plus that same interest rate, but this time is compounded quarterly or monthly. So this time we use 12 instead of 4. So let's see what happens when we plug that in. So now we're going to type that straight into the calculator. 1,500, 1 plus that same interest rate. Oh, 4, 4, 3, but this time it's 12 to the 12 times 6. Oh, I forgot my parenthesis. Sorry. Let's try that again. 1,500, 1 plus 0.043 divided by 12 to the 12 times 6. There we go. $1,940.61 is our answer. So again, my expectation, I need to see you putting the values into the formula, and then you may use a calculator to just get the answer and write the answer down. Now I want you to notice, the only thing that changed here was the amount that it was compounding by. Okay, this was compounded monthly instead of quarterly. So notice when it compounded more often, when everything else was the same, how were our values different? Well, it didn't differ by much, but the more that it was compounded, if you notice, you got a little bit more money at the end of that 6th year. And the reason for that is because as it's compounding more often, you're making interest on your interest more often. Okay, you get more opportunity to make money off of the interest you've already accumulated because they're calculating the interest more often. Okay, so it sounds a little confusing, but if you really think about it, it makes sense. The more you can make on the interest, the more money you're going to end up with in the end. Suppose you invest $500 in a savings account that pays 3.5% annual interest. How much will there be in the account after 5 years? Okay, so here, how much are we handing the bank? We're handing them $500 at 3.5% interest. Well, that's just 0.035. Here, all they say is annual. So we're going to assume that we're just getting that interest annually, once per year. And after how long? Well, we're curious about 5 years. So let's plug that in. 0.035 divided by 1, 1 times 5. Now here, I hope you see something interesting happen. So when n is 1, when you're only making that interest once a year at the end of the year, notice what happens. Because of those ones, that should look familiar to you. That isn't that just this? So when n is 1, what I want you to notice is that is actually identical to the growth model that you learned yesterday. So that's kind of the cool thing, is this model actually is essentially the same as the other one. When n is 1, you get that very same equation back. So that's something I think is really interesting, a nice connection to make. That annually is just that normal growth. Okay? So let's plug that into the calculator and get our answer. 500, 1 plus 0.035 to the fifth. So we're going to have $593.84. Oops, sorry, 593.84. All right. So now we can still do the same thing we talked about in yesterday's notes. What if I want to know how long it's going to take me to get above 700? All right, so if I want to know how long it's going to take me to get above 700, remember, I'm going to make a table for that. Now we already have a piece of information. We already know after 5 years, we have $593.84. So we know the answer is going to be more than 5 years, right? So let's go and work from that 5 years. So we have this formula. We have that formula. So let's start plugging in years and seeing what happens. So let's see after 6 years how much money we have. After 6 years, we have 614 about. Okay, and then of course there is a decimal, but that doesn't matter because we know that's not the answer we're looking for. What about 500? 1.035. Oh. Let's try to the 7. 636. Let's see, after 8 years. $659. After 9 years. Still not quite there. Let's try finally if 10 years will cut it. There we go. For the first time, after 10 years, we finally have over $700. Okay, so after 10 years, we finally get over the $700 benchmark. So that's going to be our answer. It's going to take 10 years for us to hit that amount of money. And don't forget, we talked about that yesterday, about when you're trying to figure out how long will it take. The answer to that is make a table and then just see after how long is it going to take me to get up to get that amount of money. All right. So for your summary, again, here I've put in a prompt for you. because this is a really cool and interesting concept that I want you to know. I know I've already discussed it, but I want you to reiterate it in your words for me because I didn't actually write it in the notes. All I did was discussed it. So I want you to look and see. Answer the question, what happens as n increases? What does it do to your money? And when you're done with that, please make sure to have all these filled out and then come back to class ready to do your practice work.